Hello! In this episode of Finno-Greek machining, it will not be welding. Well, actually there is a very good reason for this. I'm going to get a better welding machine. My Kemppi, which is 50 years old, well, it really is 50 years old. Well, there has been some people who say that this is a bush box. Well, it's not. Yeah, there is a big transformer inside, but in this case there is rectifiers and some thyristors in order to utilize this current adjustment by potentiometer. So actually this is a DC welder. At the time when it was sold as new 50 years ago, when it was brand new, it was probably the best one could buy in Finland with those features. It is really and it's still quite a good welder. But there are some things which make it very hard to use, like it doesn't have this high frequency ignition, so you have to scratch and then your sticks stick. Well, okay. But in the next episode we will be seeing whether I can get a better one. I put a picture of that like a teaser, something like that. Okay, and now in this episode then, we are going to make two lathe tools. One is for my rhombic inserts, which I use very widely, and my Chinese insert holder it's so soft material that it just isn't any good anymore. So I make a new one from Uddeholm SV-51 tool steel, which is actually quite hard as it is. I don't heat treat on it, it doesn't need to. It's as hard as it is. And then we make another brazing using the brazing method. So you will be seeing two holders. The other one will be milled pockets, etc. for those inserts, and the other one will be just brazed carbide tip on top of some steel rod. That's it. It's very easy. Okay, yeah, I mill a pocket there, etc. I don't show that on video because it's so simple operation really. But, well, let's start. Okay, this workpiece is the tool steel, and I have already milled it to be square and for proper dimensions. Now I want to dial it in so that that far corner there, that corner, will be our reference point. And well, this is pretty simple. I just put it here and then come here with this Heimer, and there you are. That's the first one. Okay. And then I will dial in this as well, this direction, the Y. The previous one was the X, and now the Y. And yeah, well, the Y is already set. It was from the previous operation because it's relying on the back face of this, the fixed jaw of this Y's. So we are ready to go with this one. So next step, I will drill all the holes here. There will be 4. Well, actually there will be more. There is two through holes and then some recesses which are round. So I will make them now. The through holes can be used later on when I'm aligning, dialing in, so to say, this workpiece, because when I start doing those angles here, I lose my references, so to say. So those holes are really important in having the references still in place. So, well, now, well, actually I just change a little bit of tooling here and then we go. Okay, now this tool holder has an M5 thread here, and since I didn't have the 4.2 mm drill to make the suitable hole for tapping, and I had to use 4 mm. That might be a little bit tight, and therefore I do it as early as possible, this one. So if it now breaks the tap, so I don't lose too much work, because if this tap breaks into there, well, this is next to impossible to get it away from there. And now I'm just using, this is a Rocco, it should be the best possible cutting fluid for this purpose. And now let's see how we can, if it does the trick. So far it doesn't feel too heavy. Well, maybe. Well, this maybe. This is tool steel after all, so okay, now it starts to feel a little bit tight. So I back up a little bit. Okay, we are through. Ah, yes. Oh, okay. I was really afraid that this tap would break into there, because it's always a little bit hassle to tap in a tight hole. That's one sure way of breaking your tap. But in this case it seemed to be alright. Oh yeah, okay. Well, we have a M5 thread there. I hope so. Okay. Well, now next steps will be, I start now milling the features on that top surface, and this will be a little bit different angles and so on, so I need to adjust the angles. Okay, now the next operation here is to, well, mill a slot, a very small slot here. And I want to align this piece to the start of that slot, and well, here is a 3mm pin, and that is a 3mm hole, which is, it's very accurate. Well, yeah, okay. And then I just lift my table first, like this. I will be using the top of the vise as table for these. Oh, let's see. I don't want to. A little bit more, like that. Okay, now it's there. Yeah, I can still move it, and yeah, okay. So now it's located quite exactly there. And then I have my clamps here. Sorry, I might be on the way of your view, but well, I have here these okay, there you are. Okay, now that's there. And then well, I'm going to use the side of this mill, this vise, as reference. It doesn't matter if I always use the same side. So then I get the angles relatively correct. And this is now adjusted to the required 12.5 degrees. So I put it here in the back side, and then I just have that way. Oh, where is my, there is that one. So, and I think we are done here. Oh, not very easy to do. I would like to have 3 hands here now. Okay. Hopefully I can get it tight. Okay. Yeah, that's now done. And then I just tighten it there. There you are. Oh no, that's not good. It this seems to lift this side up. Not good. Why does it do that? Oh man, not good. I need to have it even nearer that thing there, I think. Aha, okay. This needs to be higher. This like that. Maybe now, not yet. Maybe now. Still. That was the reason why it was so. Well, now it's pushing at the tip of this thing, And this is not easy to do. Put it as far as possible and a little bit more even. Oh yeah, now it's pushing it. So now we need to do this again. It was lifting that side up. Okay. Okay, let's see now what happens here. Okay, looks good. It was lifting about 1 millimeter, that one. Not good. Oh yeah, now it goes. Now it's there. Yeah. And then I just can pull my pin out from there. And I have locked the vise. So now I will use X direction to create that thing. Now I just change the mill there, it's in low gear, good. Yeah, this is, well, this is high HSS high-speed steel pin, really. These are accurate. And then I have here my mill, which is a 3 millimeter round nosed, but yeah, okay. So put it there. Now I have to look that it's there so that we have room there a little bit higher. That maybe. It's very hard to predict where is the good place, but that should do. Okay, and now next step is to mill the slot. It will be like 5 millimeters deep, and well, the specification was 3.9 millimeters, but I make it deeper just to be sure that there is enough space. You will be soon seeing what is this for. So, well, now we can release the X-axis. Y-axis remains locked. And this is totally manual. I don't want to do this at all. Let's see now. I have to touch it somehow first. Well, but yeah, I can see it here. That's our 0. 5 millimeters has already like 2 millimeters extra. So now I just retract it a little bit. Sorry, I was a little bit. Go to there, in the middle. Well, the X-axis is so sensitive, not sensitive, it's so easy to move that I lock it a little bit. So that it, yeah, now. And then we have to run this quite fast. Okay, it's around 550 revolutions per minute. And then so this was 0 and 5 millimeters down. So it is 1.5, 3, 4.5 and 5. There you are. Now, that should be it. Oh, let's see if I break my end mill here. Yeah. Okay. Then we go, I believe. Wow, I did it instead, huh? Yes. Nothing more than that. Wow. It should be alright. I have to look with my optimizer here so that it really is. Yes. It sure is. Yeah. Oh yeah. Okay. Now I test it. Well, this is now... I will take you a closer picture about this because you cannot see it otherwise. Let's blow it a little bit. Yeah. There you are. And then the picture. Like that, maybe. Yeah. And now what I have is a clamp that goes into there. I bought from eBay tool holders for these, and this small thing here is a clamp that should now go into there. I have to fetch my Allen wrench. This is just a test if I need to. No, I don't. This is exactly. Yeah. Okay. Looks perfect. Yeah. So there it is. I'll take a picture out of that so you can see again. That. And now it's just to mill the slot for this insert here. And yeah, this will be working really well. So now the next operation is to mill here tilted with a tilted angle away from this end. Well, the document says that this angle here and there should be 72.5 degrees. Okay. So how to do this? Well, we have to tilt this to the correct angle. And how to do this? Okay. Here we have this hand wheel, and this here up we have the brake for this this cylinder. So I release the brake, so, and then we have here a graduation. So here is the graduations. This is the scale, and we are at the moment at 90. So it should be 72.5. Yeah. Okay, not that way. This way. 72 point. That's too much. Yeah. Yep. And now I just lock the cylinder by pulling this. It's locked, and we are ready to go. Okay. And now I just blacken this so that I know how much we have to go here under. All this black should be removed. Not more, just the black. There you are. And then no rabbits in this one. Manual rabbit. that's about in the halfway. So I zero my scale here so that I know how much I'm peeling off every time I go here. So, and we should be doing this with quite a high speed. It's about 500 revolutions per minute now. Now we go. We are very near. We are very near. I'll take only now 1/10 of a millimeter. My wrench went out from the slot here. 1/10 only. There. Again. Well, I think we need to take a little bit more, but it's 1/10 and there you are. Then we are there. Yeah, this is the last part. I try to be very slow with this one. And now these chips here, they are actually very nasty. So I vacuum them, most of them. Yep. Those are good filling for hardcore machinist. Good pillow filling for hardcore machinist. Yeah, okay. That's done now. Next step will be the other side of this workpiece, but I'll come back to that when I have done my adjusting here. This is now the holder for the DCGT rhombic inserts. After all, it became quite good. It does not have a fancy finish, but it is perfect where it matters. The insert sits well in its pocket. It is supported everywhere underside as it should be. The side walls of the pocket are straight and in correct angle. I decided not to turn the 7-degree tilt on the side walls. Close inspection to the late Chinese holder reveals that it did not have those either. Using a clamp from a scrapped holder works really well. This clamp pulls the insert into the pocket and pushes it down at the same time. The M5 thread is also much more reliable than the thin screw. Let's try the tool where it is supposed to be used. First I use it for facing with varying cut depths. Note that the tool is already adjusted to center height. That facing did not have any drama in it. The surface finish is typical for mild steel with this type of an insert. Now, let's turn 1 millimeter out of the diameter. Nothing to report here either. This is a good general turning tool. So, this here is the other lathe tool I'm going to make, and this is going to be brazed. We have a insert like this, which I will now silver solder into that place. And first of all, this is in a position that it's tilted so that gravity takes care of keeping the insert in that slot. So first we have to put some flux into it, and it's this, superior black stuff, which is quite something. Oh, is that too much? Maybe. Let's take a little bit away from it. Well, that will suffice. So I just push it there, and then I will wipe off the excess. I don't want this stuff to go everywhere. Well, it goes everywhere anyway, so okay, there you are. About there. Okay, here at the end we also have some. So you probably noticed that I had made quite a chamfer in there. So this chamfer is there for me to easier get my silver solder where I want it to go. So now we just start warming it up. I'm using this special butane torch. It takes the air near here and mixes it while it's traveling in the tube, and then the resulting flame is, well, it's quite hot. Let's see if I can get this going. And now you have to be a little bit careful when warming this up so that you don't like boil. You have to warm it slowly, so to say, at first. Now let it be there for a while. Okay. Then. And now we just, as you can see, no, you can, yeah, you can see. I'm actually heating the shank and not the place of the insert at the moment. I'm trying to get it as warm as possible before I start. Maybe we can, okay. A little bit more heat. Well, it already has moved a little bit. It likes to move. Okay. I think I'll take a tool like this to position it when needed. Okay. Okay. Yeah, it likes to move. Really likes to move. For some reason, I don't know why. It should not move that like that. Okay, now. Well, starts to become red, so now I wait until it's really red, and then I put some of this into there. Well, it doesn't want to melt, this one. Now it is. Now it should just follow the heat. Well, I need to have more there, I think. Oh. Oh no, yeah. Now just wait so that it goes all over the place. Okay, now it goes. Yeah. Okay, I can see it seeping here, back in the backside. Well, yeah, okay. Maybe I should wipe the excess away from there, yeah. Oh yeah, it's all over in the underside and everywhere now. It's I can see it all over there. And now we just wait. We need to give it time to cool down. You don't want to drop it into something hot water or cold water or something. It will destroy your bond right away. Actually, it will crack the carbide. Well, that should be a very good joint now. We just wait to cool down. Oh yeah, I will show it. This flux is something that is soluble in warm water. So when it has been processed like this. So, well, yeah. Hopefully we have it well in there. I think we have, but you never know. Yeah. Well, yeah. Well, let's see. Yeah, those were the two, tool holders or carbide tip holders for my lathe. Both are right turning tools. Yes, right, I believe. It's going to the... Both are used to turn pieces from away from tailstock. I don't know whether it is a right or left turning tool. I'll figure out whether it is. Let's see. So, in the next episode, as I said in the very beginning, we will be having a new welding machine, new to me. It's not new, and we will inspect it, clean it up before using. When you buy a used equipment, it's I want to see what's inside, if there is some grinding dust, etc. Well, the welding machines are used usually in an environment that contains a lot of that stuff. So yeah, and well, then we are probably going to try to weld with it. So that will be in the next episode of In-Off Machining. Till then, bye!